Welcome to ePathshala lecture series in computer science, and this is a course in cloud computing. In this module, we are going to talk about management of cloud. Today's learning objective, first we will look at what are the cloud management functions, what do we mean by cloud management and what are the functions. In that we will look at the orchestration, and then we will go on to look at resource monitoring, and we will give a brief introduction to security of cloud, followed by summary. So, what is cloud management? What do we mean by management? Cloud management refers to managing everything that are part of cloud. So, all things put together, whatever comes will be the cloud management. So, that includes the resources, the environment, the services, the security procedures, the user profiles, everything, all things put together. So, the reason why we need cloud management is to ensure that the whole function, the whole environment, the overall cloud ecosystem is working, functioning properly. So, that we have implemented the standards that are required for this and maintenance of all the services and resources, and overall workflow automation is done properly. So, whatever comes within the purview of cloud will come within the purview of cloud management. So, we say that cloud is an amalgamation of all these VMs, services, networking, and more complexity is coming into the cloud. How more complexity is coming? We are seeing the virtual private cloud, that is a new concept that is coming in. We saw the VPN and how VPN is helping cloud. More and more VPN is getting integrated in cloud. So, that is another complexity that is coming. We are seeing rapid cloning of VMs for faster deployment. We are having rapid cloning of VMs, which are increasing the complexity, and we are having new theories, new philosophies which are creeping into cloud system. One example is follow the sun, that is also a part. So, how to manage such complexity is the work that we are going to look at in this module. So, to manage this overall complexity, we have three facets. The first is the resource management and orchestration. The second is the resource monitoring. Management says, am I doing it correctly? I must apply proper rules to do it correctly. I am going in the correct direction. I have taken all the precautions for it. Monitoring says, I will check whatever I am doing, whether that has been done correctly or not, or are being done correctly or not, and whether the whole system is secure. Why security is a special part of management is because there are major concerns about cloud security, and therefore, it has to be looked at very specifically. So, what are the components that we need to manage? Everything: data center, hypervisors and any middleware that we have, the software stack, the applications, databases, storage systems, then what security we have implemented, and all the business units, including all the infrastructure that this area. So, what are the factors in cloud management? Cloud management has to take care of the entire environment, inclusive of everything. It has certain functional requirements, such as it should have reliability, availability, scalability, serviceability, etc. And it has a number of non-functional requirements, as in whether the rules are applied properly, whether the legalities are maintained, is it auditable, all these, is it compliant to the norms of a certain government, etc., are all part of non-functional requirements. So, first let us look at the resource management and service orchestration. Resource management actually we have looked at in an earlier module where we discussed the resource management and scheduling. So, large part of resource management is actually part of scheduling, where we have the global scheduling and the local scheduling. Apart from that, we looked at profiling of resources, utilization estimation, overall workload management, etc. So, that whole thing actually should be also part of the cloud management. Then comes orchestration. What is orchestrator? Is a program that manages interconnection and interactions between various services. These services are cloud services, plus an orchestrator also is supposed to look at the on-premise other business services that are available. So, the orchestrator has to take automatic actions, automated actions, and it has to also connect to external software. It has to decide when an error has occurred, and it has to decide when to stop and back out. So, these are all orchestrations. Now, do we really need orchestration? Let us look at what exactly is the need for having the orchestration. We have this compute, storage, and network resources. Service orchestration or service abstractions are done by orchestration. So, why we need service orchestration or abstraction? Here is an example. A customer wants a service, but the customer says that the price is too high and the cost is too high, can you reduce it? So, how can a service provider reduce the cost of a specific service? We can try and consolidate resources. We can look for a resource which is cheaper than what is the normal resource that are being utilized. We can use the cycles, the computer cycles that are going anyway free, so that the cycles cost less. If we reserve a chunk of computer cycle for a specific service, the cycle costs money. Whereas, if we just look around and get such cycles which are already free, then it is cheaper, and we use a lesser bandwidth environment. Thereby, the normal cost of the service in a proper environment, how it would cost, the cost will come down. All these are job of an orchestrator, to look around, to find those specific places, requirements, and apply. So, here is an example where we see that here is a client, and over the internet the client is accessing what is a specific virtual machine or data center, and it is communicating with the data center. Now, if we decide that this data center is too far off and the cost is too high, what we can do is we can look for another data center which is nearer to the client. But what we need to do about the virtual machine, we can stop the VM there and bring it back here. That is one option. The other option is to move or migrate the VM. This is called a live migration of virtual machine, wherein we do not stop the workings of the VMs and we do not let the client actually know that there is a migration, but we move the VMs on its own. So, we create a virtual private network and move the virtual machine while the client is still talking to the original virtual machine, and we ensure that the orchestration must ensure that the IP address and other things, all the files, etc., are all available here and unchanged, and then finally we let the client talk to this VM. Since there is no change in the IP address and stuff, so the client remains, it totally remains transparent to the client that the VM has been moved. Actually, this is the mechanism used for the philosophy called follow the sun, and this is totally a job of the orchestrator. The next part of cloud management is resource monitoring. What is resource monitoring? The importance of resource monitoring, the job is to monitor the resources, how they are working. Both provider and consumer need resource monitoring. provider so that they get better control of the system, consumer so that they understand what is happening, the key performance indicator is known to them. So, monitoring is the mechanism that you use. So, what is the need for monitoring? Let us look at a few examples that has happened. In Amazon in September 2015, the cloud services failed when they did something with their metadata. The users could not access the Amazon cloud services. In another system called Verizon, the power outage in Verizon data center actually affected a customer called JetBlue Airways, they are an American airlines, where their passengers could not book the flights and they had many problems. That happened in January 2016, but Verizon did not reveal which other data centers that got affected. Salesforce.com, a big giant whose CRM software is the famous for it, continuous outage in Salesforce in 2016 May caused their customers all their data for 4 hours, whatever data they had entered had been wiped out. Salesforce eventually retrieved the data and they claimed to have done it properly, but without a proper monitoring it is not possible for the clients to know whether actually it has been done properly or not. We continue our examples with Symantec, which is a security company, very important that they have all their mechanisms in place, but for 24 hours in April 2016 there was an outage and nothing could be accessed. Twitter was out for 8 hours in January 2016. Microsoft Office 365 was unable to access their email accounts. Users were not able to access email accounts for many days, and Google Cloud was out for 18 minutes, and Google has made all kinds of adjustments to ensure that their clients are compensated. But the point is, what has got affected, how much is what is the extent to which these outages affected their data, their resources that are there in cloud, the customers have a right to know. So, monitoring helps customers largely this way. So, here are the functions: capacity planning, data center management, troubleshooting, performance management are typically done by the cloud provider, are done for the cloud provider. SLA compliance and auditing, disaster recovery process, metering and billing are both the job of the provider and the consumer, and risk assessment and security, monitoring, risk assessment and security are to be done by the consumer. So, let us quickly take a look at capacity planning and management. So, providers must know that how much capacity they can commit in terms of the QoS through SLA, and monitoring gives them the power to understand the capacity and plan for it. Data centers are the facilities where all the infrastructures will be kept, and these are the possible elements. We have the building, then we have all the components, we have the IT and non-IT components and the staff members that are part of the data center. There are 4 types of data centers. One is the basic data center tier 1, where we have a single data center. We have tier 2 which has a disaster recovery. That means that they have a parallel data center elsewhere physically in a different location, so that in case of disaster this data center will be affected, but the data and resources of the customers will not be affected. So, that is, if I have a corresponding data center which is the disaster recovery data center, then I have tier 2. In tier 3 we have DR, which is a disaster recovery, and plus all the data centers are having a dual power source. So, a power outage will not ever cause any problem, and a tier 4 has a tier 3 data center along with a special cooling. Cooling becomes a very important concern for service providers, cloud providers, and having a special cooling facility will be giving a tier 4 data center. So, how do I manage data centers? Cloud providers will have these large gigantic infrastructures along everything, and every bit of these gigantic infrastructures must be monitored, and data must be obtained and analysis must be done to ensure that everything is going fine. Troubleshooting is part of that. These information will come through, and when there is a problem we can easily obtain where the problem has happened. On the consumer side, troubleshooting says that the consumer must understand if there is a repeated failure, why it is happening and what the provider is doing. Performance management, all the mission critical services, maybe some scientific applications, their performance there is a great concern. So, some nodes may be affected, performing badly, some are doing well. Consumers need not implement any hardware performance infrastructure measures, only done by the providers. Service level agreement, a very important document in case of cloud. So, this is a format explaining the what kind of service the consumer is going, provider is going to provide, the consumer is expecting, what are the guarantees regarding QoS, what are the arrangements, etc. Everything will be described clearly in a service level agreement, and guarantee of preserving the service quality that is satisfactory for both, and all the stakeholders must understand there. So, SLA is that document which contains the following: the availability, performance, security or privacy, disaster recovery, location of the data, access, how the customer is going to access the data, portability of the data, whether the data is they are able to move the data from one place to the other, change management, updates are reflected how often, etc. If there is a dispute, how to mediate, and the exit strategy. SLA must have all these points clearly defined for both the customer and the provider's point of view. So, SLA is it improves the right to audit, it enhances relationship, and it enhances the overall quality. There are two types, one can be a manual SLA and the other is a machine readable SLA which contains all the factors. Very close part of an SLA is the QoS, because large amount of the deliverables are not quantitatively measurable. So, therefore, QoS metrics are used for defining them qualitatively, and therefore, how to assess the QoS parametrics are important. So, how to measure and how to monitor in terms of speed, accuracy, availability, reliability, security. I say it is reliable, but how much reliable is it will be a measurable quantity. Simplicity, flexibility, capability, usability, all these are QoS parameters that are used by the providers and consumers. Disaster recovery, in case of any physical disaster, the system, there must be another backup data center from where all the data should be recovered in case there is a natural disaster. So, and this should adhere to the SLA that have been guaranteed by both the parties. Business must continue. So, the continuity plan must be part of the disaster recovery and prevent the business to be affected in case such disasters happen. Metering and billing are again a very important part, because cloud is a pay as you go model where customers or consumers pay the amount that they have consumed. So, somebody has to measure the amount that has been consumed. There should not be a doubt in that, because consumer has to pay proportionately. So, depending on the type of services, we can decide the amount that has been consumed. For example, in case of SaaS, we say the number of users or the total number of users or the application performance can be the measure. In case of PAS, it will be the CPU utilization or the amount of time, and in case of IaaS, the number of VMs. Again, monitoring becomes a very important part, that am I being charged correctly is a question that the consumer is going to ask, and service provider has to give that guarantee that yes. So, they have to be transparent enough to be monitored by the consumers, thereby allowing them to understand that yes, that all these are happening properly. So, consumer need to verify the metering and billing mechanism. So, what are the properties of a monitoring system to operate properly? It should be scalable, it should have elasticity, it should be adaptable to the kind of environment that is being monitored, it should have timeliness. It will monitor and give its result after 5 days, it really does not matter. So, it should have timeliness, it should have autonomicity, that it can take a decision and self manage itself in case something goes wrong. It should be comprehensive, so that it supports all the possible types. It should be extensible, it should be intrusive in that if cloud need to be changed for something, that should be allowed. It should be resilient in that it always delivers irrespective of failures, and it should definitely be reliable, that whatever data it is giving, that data is accurate, correct. And of course, such monitoring system should be available, and accuracy must be guaranteed. There are quite a few monitoring tools that are available. Nagios is an open source monitoring platform that has been extended to support the monitoring of cloud infrastructure. OpenNebula is a very popularly used tool that can monitor all the infrastructures in a cloud. PCMons are a monitoring system, and Dargos is another distributed cloud monitoring architecture that is for hybrid cloud. In fact, there are many monitoring tools that have mushroomed in the industry today. To use a specific monitoring tool, we must be careful as to what the monitoring tool is providing, how the mechanism is working. The last part of the cloud management is security. When we talk about security, it must give the guarantee on that everything is happening as per the requirement. Security has many facets. Is my data safe will be the first security, the point of security that we need to talk about. Then when I am moving my data from one part to the other, when the service provider is moving the data from one part to the other, are you moving the data as per the regulations and norms that we are providing in the according to the rule of the country? When I am deleting my data, I store my data in the cloud server, and then I am done with that data and I want to delete the data. The deletion of the data, is it being done properly? Is it being done appropriately? Is again a concern of security that has to be maintained. Sometimes in a business we have the situation where maybe some rival group will get access to the data, and the cloud provider just keeps a copy of the data in store and does not and misutilizes it. So, security has different facets that has to be looked at by the security mechanism. So, to summarize this module, we looked at the cloud management. We saw that the management is a very important part of a cloud environment, and it should manage the basic 3 items in a cloud, which are the servers, the storage and the networking. It should manage the services in terms of doing orchestration, etc. It should manage the users in by ensuring that the monitoring is done properly and users are billed properly, etc. It should manage the infrastructure so that everything is going on properly and everything, all parts of it. So, we looked at three typical parts, which is first the resource management and resource orchestration, thereby we provide the perfect service to the consumers. Then we looked at resource monitoring, by which we assure the consumers that everything is fine and we can take, a provider can take a decision whether how much to commit, whether to commit, whether it is being done properly or not. And the third part is the security, which we will look at in the next class. These are our references. Thank you.